Building a real-world snake game project. Welcome to this session. Today we are going to create a simple but exciting project, a snake game served as a web app using Django. Let's break down step by step. Key goals. Use Django to serve the game as a web app. Second, use HTML, CSS, and JavaScript for browser-based gameplay. Third, use Django views to handle backend logic and JavaScript to manage the game's front end interactively. Project structure. We have a root directory that includes manage.py, handles project commands like running the server or migrations. db.sqlite3 stores the project database. And we have app directory snake, which includes init.py, admin, apps, migrations, modules, tests, views, URLs, and templates, subfolder snake, and game.html. And we have static subfolder snake, CSS, style CSS, and JS, game.js. Finally, we have project directory that includes settings, configures the project including installed apps and static files, main URLs.py, connects the main URLs to the apps hooks. This structure keeps the front end and back end separate, ensuring the project is easy to manage and extend. Step 1, project setup. Create a Django project. Run the following commands to create your project and navigate into the directory. Open a new Anaconda prompt. Conda. Activate. EJ. Django. Admin. Start. Project. Snake _ game. The project created. Now change directory to snake game. Now create a Django app. Within the project, create a new app called snake. Python manage.py startup snake. Now add the snake app to the installed apps list in a settings.py. We add this snake app and save it. Step 2, front-end implementation. You will use HTML, CSS, and JavaScript for the game interface and mechanics. Create the template. Inside the snake app, create a folder structure for templates and static files. Snake, right-click, new folder. We name it templates. Inside templates, new folder, snake. Now we create a new file, name it game.html. Enter. Inside the snake app, you also create another folder. We name it static. Enter. Inside static, new folder, snake. Enter. Inside snake subfolder, we create new folder. We name it CSS. Inside CSS, we create new file. We name it style.css. Enter. And inside snake, we create another subfolder. We name it JS. Inside JS, we create a new file. We name it game.js. Game HTML file. After updating this code, we use Ctrl S to save it. This code creates the game.html template for the snake game. It loads a static file, CSS and JS using Django static tag. The HTML structure includes a canvas element where the game is drawn with a fixed 500 x 500 pixel size. The linked CSS file, style.css, styles the game, and the game.js script handles the game logic. The template integrates the necessary CSS and JavaScript files for styling and game functionality, providing a structure to render the game within a canvas. It ensures that the game runs within a styled container with all resources correctly linked through Django's static file management. Now add CSS style. To style the game, inside style.css, we add the style for body, game container, and we save it. This code centers the snake game's container in the middle of the screen using Flexbox. It removes default margins, sets the body background to a dark blue, and gives the game area a light teal background with a blue border. The fixed 500 and 500 pixel game container is visually distinct and positioned relative for future content placement. Now add JavaScript. Inside game.js, we added the following code. Ctrl S to save the code. This JavaScript code handles the logic of snake game. It uses the HTML5 canvas elements to draw the game, where the snake and foot are placed. The snake moves based on key presses, and the game checks for collisions with the walls or itself, resetting if either occurs. The snake grows when it eats food, and new food is placed randomly. The game loop updates the game state and redraws the canvas every 100 milliseconds, providing continuous gameplay. It also manages user input to control the snake's direction and resets the game on collision. The game loop ensures smooth real-time updates. Step 3, backend implementation. Starting with the create a view. Edit views.py to render the game. From Django.shortcuts import render. Define game request colon return render request comma snake game.html. We save the update of its code inside the views.py. This code imports the render function from Django's shortcuts model and defines a view called game. The game function takes an HTTP request as an argument and returns the rendered HTML page to be displayed. Add URLs. Create urls.py inside snake directory. Right-click New File. urls.py. Enter. Inside url.py, we added from Django.urls import path, from .import views, URL patterns equal path, single quote, comma, views.game, comma, name equal game, and we save it. Also, we should update urls.py inside snake_game. From Django.contrib, import admin. From Django.url, import path, comma, include URL patterns equal path admin, path include snake dot urls. Control S to save it. This code sets URL routing for a snake game in Django. The root URL is mapped to the game view. From views.py, we added static root to the settings.py. Static root equal os.path.joins base underscore directory comma static files. Control S to save. Import OS and static root.
Step 4. Run the server. First, collect static files. Python manage.py collect static. Yes. Now run the development server. Python manage.py run server. Control, click on the link, and that's it. We can change the speed of the game inside the game.js JavaScript by changing set timeout. For example, from 100, we change it to 150 to be a bit slow. Run server again. Conclusion. You have now built a fully functional snake game using Django. This project demonstrates how Django can serve dynamic web apps and integrate with the front-end technologies.